right, so in this little section we're going to be talking about a very, very important skill, and hopefully you remember how to do it. It's dimensional analysis, and also we're going to be talking about scientific notation because a lot of the numbers that you'll see are in scientific notation. So you need to be very comfortable with those numbers. Alright, so scientific notation are numbers written like this. So some number followed by multiplication sign and 10 to some power. And really this is the way we write really big numbers and really small numbers. So basically this means 6.02 times 10 to the 23rd. Well, I take that number and I just move the decimal 23 times over and then add zeros, and then that would be my number. So if you want to convert into scientific notation, you're going to move the decimal until there's one non-zero to the left. So basically if you have a number like 1080 like this, and you want to convert this to scientific notation, well, go to the end of the number, so there's no decimal point there, but you can just pretend like there is, and then just keep moving it over until there's only one non-zero in front of it. So there, I have one in front of it, or to the left of it, rather, to the left of the decimal, and that's what I'm going to do. I'm going to move the decimal point, and basically the number of times that I move it is the exponent. So I moved it 1, 2, 3 times, so it's 1.08 times 10 to the third power. Well, for that exponent, you're going to have positive numbers if it's a number greater than 1, and you're going to have negative numbers if it's smaller than 1. So like a small number would be like 0.001, okay? Because that number is less than 1. So that would have a negative exponent. Numbers larger, even if it was 10, that would have a positive exponent on it. Alright, so let's just do some examples. Alright, so if we're going to look at this number and we convert this to scientific notation, so all we do is we go to the end of the number. Right here, there's no decimal point, but that doesn't really matter. You just move the decimal until there's only one non-zero to the left of it, which is right here. So I just move it. It's 4.2. The rest of it, well, the exponent is going to be the number of times I moved it. So it's 1, 2, 3, 4. 4 times. And since this is a number that is larger than 1, it's got a positive exponent. Alright, so for this one, small number, so I'm going to move the decimal again. I'm going to move it until there's one non-zero to the left of it. So move it the opposite direction. 1, 2, 3, 4. Okay, so now it has one non-zero to the left of it or in front of it. So it's 1.2, and that's when I stop, times 10, and I moved it 4 times, but since this number is smaller than 1, it'll be a negative exponent. Alright, so for this one, again, do the same thing, go to the end, move it until there's only one non-zero in front of it, so 1, 2, 3, 4. I moved it 4 times, it's 2.45 times 10, moved it 4 times again, and it's positive exponent because it is larger than 1. Alright, even though this number doesn't necessarily, it doesn't really warrant putting it into scientific notation, you still need to be able to do it. So now we're going to take the decimal, move it again, so 1, 2, until there's just one number to the left of it, or in front of the decimal. 3.56, and I moved it, well, I moved it once, twice, so 10 to the second. And it's positive because it's larger than 1. Alright, so for this one, I'm going to move the decimal until there's just one number, one non-zero in front of it. So now it's at 9.85, and I moved it 1, 2, 3, 4. I moved it 4 times, again, coincidence, complete coincidence. And it is smaller than 1, so it will be negative 4. Alright, for this one, move the decimal 1 time, 2.22 times 10. I only moved it once, and since it's smaller than 1, it will be negative. Alright, so this is just converting it into decimals, or into scientific notation. Now, if you wanted to go the opposite direction, which you can, what you're going to do is you're basically just going to move the decimal, and then if you need to, you're going to fill in with zeros. So you have 4.2, okay, times 10 to the third, so you're going to move the decimal 3 times, and since it's a large, or since it is a positive exponent, that means that it's going to be a large number or a number greater than 1. So that means that you're going to move it to the right. Basically, if it's positive exponent, you're going to move it so that the number is larger than 1. If it's a negative exponent, you're going to move it in the opposite direction so that you have a decimal in the front. Okay, so I'm going to take my decimal, move it 3 times. 1, 2, 3. And now I fill in with zeros. So it should be 4,200. Okay, so that number doesn't mean, it has 3 zeros on it. It means that the decimal needs to move 3 times. Alright, so this one is a negative exponent, so I'm going to move it in the opposite direction. So we've got 2.15 here. I'm going to move it so that the decimal is in the front. So 1, 2, 3, 4. This is a little sloppy, so now I fill in with zeros. So it's 0.000215. Alright. So now let's look at the next one. It's 3.14 times 10 to the negative 6. Well, negative exponent means it's a very small number, so that means I'm moving it so that the decimal is in the front. 1, 2, 3, 4, 5, 6. Now I fill in with zeros, so 1, 2, 3, 4, 5. Alright, so now that number is just 0.0000314. Alright, so now this one has a positive exponent. So now you're going to move the decimal to make it large. So we have 9.22. Move it 5 times. You're going to move it in this direction because it's larger than 1. And that's 1, 2, 3, 4, 5. Fill in with zeros. So 922 followed by 3 zeros. Sloppy. Alright, so same thing here. You're going to move it twice, and you're going to make the number large. So I'm going to move it this direction. 1, 2. So it's just 957. Alright, so make sure that you have this down pat, because we are going to be using scientific notation a lot in this class, especially when we get to acids and bases, because we look at such small numbers. Alright, so in the next video we're going to do dimensional analysis.